Okay, so hi. So let's do this question, which involves the superposition theorem, and it tells we have this circuit over here with two sources, one being a voltage source and one being a current source. So the voltage source is here over there with 6 volts, and the current source is here with 1 ampere flowing in this direction. Then we have two resistors, and we need to find the current through the second resistor. We need to find the value of the current flowing through and the direction it is flowing through. So let's go ahead and attempt it. So yeah. So the first step, right, is in order to use the superposition theorem, we need to turn on the sources one by one. So in the first scenario, right, we're going to turn on the 6-volt source on and the 1 ampere source off. Right. So we turn on the first one and leave the other one off. So that's going to be result in a circuit that looks like this. So there's 2 ohms over here, 10 ohms over here, and this is 6 volts. And as a result, this is going to be 0 ampere flowing through, right? So it's going to be as good as an open circuit. So what's the current flowing through R2? So oops, I did not state what R2 is. R2 is this. So what's the current flowing through this? So this is just a series circuit, right? So the current flowing through R1, the current flowing through the circuit through R2 is going to be, so let's just call it I1 for the first scenario, right? So I1 goes to 6 volts divided by 2 ohms plus 10 ohms. And that's going to give you half an amp, right? So that's for the first scenario. So now let's now turn on the 1 ampere, right? So 1 ampere we turn on and the 6 volt we turn off. Okay, so yeah, so the direction for I1 was top down, right? So let's consider the for the second scenario. So we have 2 ohms, we have 10 ohms. So now we have the current source pushing 1 ampere downwards. And over here, right, in order to make sure that this is 0 volts, right, we need to join up and short circuit. So yeah, so now we have this system over here. So this is the 2 ohm and the 10 ohm are essentially in parallel. So what's going to happen is that the current is going to flow like this. So let's just call that let's just call that I prime, right? Through this part I prime, and then it's gonna, when it reaches here, there's a junction, so it's gonna split into the upward. It's gonna split into the one through the 10 ohm and the one through some current through the 2 ohm. So let's just call this current I2 and call this current I3. Okay, so we know that I prime equals to I2 plus I3, right? Because if you look at this junction, the ingoing current must be the outgoing current sum, must be the sum of the outgoing currents. So, and we know that I prime is 1 ampere because I prime is the current flowing through this part, right? And 1 ampere is this current source will do whatever it can to push 1 ampere through this wire. So okay, then on top of that, we currently have one equation, right? But we have 2 unknowns, I2 and I3 are unknowns. So what can we do to solve for I2 and I3? We can notice that the potential difference between the 2 ohm resistor and the 10 ohm resistor must be the same. So that means that if we denote in blue, the potential difference between the 2 ohm resistor, right, which is going to be I3 times 2 ohms, right, and the potential difference between the 10 ohm resistor which is going to be 10 ohm times I3, sorry, times I2. So I2 times 10 ohm. So I2, they must be equal, right? Because they're connected to the same, they are the same 2 points on the circuit. So I2, so 2I2 equals to, sorry, 2I3 equals to 10I2, right? So 2I3 comes from here, 10I2 comes from here, and you know they must be equal because by Kirchhoff voltage law, when we go in the loop, right, this point and this point is exactly the same point because it's joined by a wire. So this gives you, from this relation, we know that I3 equals to 5I2, right? So substituting back into this first equation, right, we get 6I2 on the right-hand side, and we get 1 ampere on the left-hand side. So we get I2 equals to 1 over 6, which is approximately 0.166666. So 0.167 to 3 SF. So, okay, so now we know that, so now we know the response if we, in the case where we turn on the 6 volts and turn off the 1 ampere, and we know the response where we turn on the 1 ampere and turn off the 6 volts. So now by the superposition theorem, right, if we turn on both of them simultaneously, right, then the effects on the circuit is just the algebraic sum of the currents. So what this means is that we have, so superposition theorem now comes in useful. Superposition theorem. So now we know that if we look at, if we turn on both sources, right? So 6 volt on and 1 ampere on, right? Then for the 10 ohm resistor, right, we have I1 going in this direction with 0.5 ampere, right? This is your I1. And then we have I2 going in the opposite direction, right? As seen here, in opposite direction with 0.167 ampere. So the net effect, right? I total, right? So the net effect is 0.5 minus 0.167 equals to 0.333 ampere. And the direction is going to be downwards because we took 0.5 downwards minus 0.167 upwards. So the net effect, right, there's more down than up. That's why this is the net. So that's answered the question, right? We have found the value, which is 0.333 ampere, and the direction, which is downwards of the current in R2. So yeah,